confirming that your presentation. Awesome. Thank you.
Good morning, everyone. Welcome to day 2 of Apricot 2025. You are in the tutorial session this morning. Apologies for people online and in the room. Our presenter was a little bit late from the airport, so I'll keep this brief. We have Swapnil Patnaker from Stresha IT Technologies, founder and CEO, presenting a tutorial session on blocking threats at the DNS layer using RPZ for threat detection and mitigation. This will be a 2-part session, so there will be a second session later on this morning. Thank you, Swapnil.
Thank you, Mark. First and foremost, my apologies for running late. At one point of time, I probably thought I should take control of the plane, but then I thought maybe that's not a good idea. Again, sincere apologies for starting late. Hopefully, the next 1 hour and maybe 1.5 hours after that, I'll make your time worth pertaining to the topic as well. All right, so I'm also a little bit short on coffee, so starting a little slow, but hopefully I'll get there. So a little background in terms of what I do in DNS. I am also the co-chair of the DNS Abuse SIG at First, so which is Forum of Incident Response and Security Teams. So that is something that I'll talk about at the very end, probably in the second session. Been doing DNS for quite some time, and I am mostly fascinated by not just the protocol, but also the fact that how you can use DNS in the context of security, right? And that's, in my opinion, one of the most underrated features of DNS, right? Everybody talks about the DNS protocol, everybody talks about how it works, but how it can be used in terms of security is very underrated. And I'm also a community trainer for APNIC as well since 2019. So been going to a number of places in Asia Pacific and teaching people, meeting people about DNS and also about network security as well. So if you don't know what the APNIC community trainer program is all about, then please after the session you can reach out and I'll tell you more about it. You can apply as well if that's something that interests you as well. And I do a bunch of training for law enforcement as well, pertaining to adversary network infrastructure tracking. So more specifically in terms of how you can not only reactively but also proactively monitor network infrastructure of the threat actors. All right, that's all about me. So a bit of housekeeping. So if you have a question at any point of time, please stop me and ask. That's as simple as it can get. Any piece of software that I'm going to talk about is open source here. There's nothing proprietary in my talk. This is all open source. It's not an RFC yet. The DNS Response Policy Zone is not an RFC, but it's pretty much supported by any open source vendor there is, right? And I'll start with this Japanese haiku, right, which talks about DNS in a very different way. I'm pretty sure you must have come across this on Twitter or Reddit or somewhere on social media, where if something goes down, people start pointing a finger at DNS, right? Saying that DNS is at fault here, right? But hopefully at the end of my 2 sessions, I'll be able to convince you that DNS, aside from many a times not being a problem, it is extremely valuable in terms of telemetry, right? When you're doing incident response as well, right? So it's not just from a defense perspective, it is also from an incident response perspective, right? So in my opinion, I think 2 very key pieces of telemetry is, one is NetFlow and second is DNS. Now, if you don't have those 2, I think you'll have a lot of blind spots when you're talking about when an incident happens and you are trying to figure out how did it happen, right? So you're going back in historical times to find out how did this security incident happen. So that's why I think DNS, and again, in the context of flow, NetFlow is something that I would primarily focus on, but this is going to be only on DNS. Now, why DNS? I think it's obvious, but just to give you, a basic idea about why DNS, anything that has to begin on the internet has to start with DNS, especially in the context of threats as well, right? So when a cyber criminal or a threat actor or an adversary is launching a campaign on the internet, let's say a phishing campaign, then they are going to use domain names, right? And those domain names are going to point to a particular infrastructure or a set of servers in an autonomous system. And the reason for that is very simple, right? That's because they want to propagate that particular threat with as many users as they can. If they share an IP address, if they share a link, which is just an IP address on an email, then the user is going to be a lot more suspicious to click it. But say, for example, in India, we have a bank called as HDFC Bank, right? And the domain name for that bank is hdfcbank.com. Now, if the threat actor is trying to launch a phishing campaign in the context of HDFC Bank, then if they send an IP address to their infrastructure to a potential victim, the victim is going to be a lot suspicious, right? This is not my bank. I don't see HDFC Bank there. But if the threat actor, say, buys a domain name, hypothetically hdfc-bank.com, and points it to their phishing page and sends it to the potential victims, then that has more possibilities of somebody clicking on it and then potentially logging into it, right? So that's why simply DNS is ubiquitous, right? It's something that not only when we use the internet, but even from a threat actor perspective, it makes a lot of sense, right? Another important point which I'll talk about now, which may be very relevant when I go to the second part of the session, is threat actors, like humans, are lazy, right? So what they will also do is they will point all their domain names or many of the domain names to the same IP address, right? Or they will use the same name servers for all their domain names, all the malicious domain names. Why? Because they're lazy, and it's easy, right? You can set up 2 name servers and you can use those 2 name servers for all the malicious activity that the threat actor is trying to do. Now, this is a very important concept to know about, because DNS response policy zones can allow you or can enable you to block domain names based on the authoritative name server of that domain name, right? And that's a very powerful concept, which I'll go into, because let's say, for example, I know 4 or 5, let's say 5 domain names of a threat actor, and they are bad, right? Let's say I know that these 5 domain names are using a particular set of authoritative name servers. Now, I can, forward thinking, I can only block those 5, right? But if I use the name server concept, if I use the name servers, and if I configure response policy zones saying any domain name using these name servers, block, right? So that's very powerful when you consider a normal firewall. A firewall will not be able to do that. But DNS response policy zones, which is also called as DNS firewall or protective DNS, can also do that, right? Then there are other elements like legitimate domain names which are being used for malicious activity, right? And I'll talk about something called as domain shadowing attack that we have been looking at, where legitimate domain names of users are compromised, right? And once they are compromised, they are used for malicious activity, right? And here the important part to also notice, the main domain is not compromised, right? Like my personal domain name is brainattic.in. That is not compromised. that is kept as it is. The threat actor will create fish.brainattic.in and they will point it to their infrastructure. So what that does is the victim has no knowledge that their domain name has been compromised, and it's a subdomain that is being used for these activities. The other interesting pivot in terms of domain names is also the free cloud hosting providers, which we also largely see pertaining to how threat actors use these. So you have something like Versal.app or cleverapps.io. So these are all providers which provide you a free subdomain under the main domain, and anyone can create a free page and host it. So we see a lot of threat actors using that. And then you also have dynamic DNS providers, right? No IP, change IP, where they use these free services to point to their infrastructure, or even to infrastructure which is controlled by the threat actor, but it belongs to somebody else, right? It could be somebody else's web hosting account, and they have compromised it. So I think I've made my point, right? Why DNS? It's quite simple to understand. Various ways in which the threat actors can primarily, use DNS or domain names to do this. A very important concept that I'll come back to is the pyramid of pain. This is basically a blog post a guy named David Bianco wrote a long time back, where he talked about the various atomic indicators and how much pain will it cause to the attacker, to the threat actor, right? So at the bottom of it, you have hash values, right? Or hashes of files, right? Then you have IP address, right? Then you have domain names. Then you have host or network artifacts, right? The TTPs, and then the tools, and then finally the TTPs, right? So you have the pyramid of pain, where what the author is trying to make a case is that anything at the bottom of the pyramid doesn't have much value, right? Doesn't have much value in the sense because they are high fidelity. A threat actor is constantly changing that. Like domain names also, if a threat actor is launching a phishing campaign, it will be very short-lived, right? It'll be short-lived for maybe a few days or maybe a few weeks, and then it will be detected and those domain names will be taken down. Or the threat actor themselves will take down those domain names. Like we have seen in one particular case where the threat actor was primarily launching these domain names, and they were themselves taking it down in every cycle of 2 or 3 days, right? Primarily to avoid detection and so on and so on. So the point that he made at that point was that the lower the indicators of compromise in the context of hash values or IP address or a domain name, the lesser the value in terms of as from a defense perspective, from as a defender. But I think I sort of think a lot differently. In the context of domain names especially, not only so the fact that the domain names are short-lived, that's absolutely true. But in certain cases, it also helps you in understanding the infrastructure of the threat actor as well, right? And using DNS, you can detect if something was accessed in your network, something was queried for in your network, or you can also do a lot of things where you are using like response policy zones to block those domain names. Like as an example, newly registered domain names, right? Why would an endpoint in a network connect to a domain name which has just been registered 5 minutes ago, right? Logically, if you think about it, doesn't make sense. Why would some endpoint in a network would be accessing domain names that was accessed maybe 1 week ago or 1 month ago? Doesn't make sense. But still, atomic indicators in DNS are a great source for threat hunting, right? So if you're looking at incident response, threat hunting, the DNS becomes extremely valuable. The other blog post that I'll point you to, which is sort of the exact opposite of what David Bianco talked about in the pyramid of pain, is analyzing network infrastructure as composite objects, right? Rather than just looking at a domain name or an IP address. If you look at all the indicators of compromise in terms of maybe even a TLS certificate, like the JAR4 hash, right? And then IP address, domain name, domain registrant details in the context of whois, which is non-existent at this point of time. But earlier historical whois is still available if the domain was registered long time ago. So the author makes the case that atomic indicators are basically composite objects, provide a lot of value in terms of threat hunting and even from a defense perspective. So I would urge you to have a longer read pertaining to the article as well. And then you have something called as in DNS you have something called as anomalies, right? Now, before I talk about anomalies, how many cheetah do you see on the screen? One? Anyone else? No. There is at least one, right? Obvious one is one, right? Any others? That's smart. Take a picture and then zoom in and. So there are two, right? I don't know if you see this little guy over here, right? You see this? Maybe at 11 o'clock you can come to my screen and probably get a closer look. So the point is anomalies in terms of threats, especially in terms of DNS, are many, right? First one, which I'll talk about is DGAs, which is domain generation algorithms, right? This is basically domains which are generated algorithmically on the fly, where those domains may not exist at a initial point of time. So when a malware gets implanted on an endpoint, the domain will be registered in certain cases at that point of time, and that particular malware will communicate with that domain, right? Same malware on this system will communicate with a different domain name, right? Which is generated on the fly. Now, there was a particular pattern in which you could detect this in terms of DGAs, where typically the domain name would be not based on a dictionary word. It used to be gibberish, right? So not something based on English dictionary or any other language for that matter. So it was a lot easier to detect that. Lot of malware families still use that method, but that is also changing, right? So something that we have seen in the last 6 to 7 months is now the malware families are generating DGAs by concatenating multiple words from the English dictionary, right? So, and the X, whatever, right? So multiple words, and now it makes it much more difficult to detect this, right? Fast flux. So why DGAs also make sense is because DGAs basically, even if I get the piece of malware and I run the malware on a sandbox, then I'll only be able to find one particular domain that it is connecting to, right? I'm not going to be able to find all the domains unless and until I do a reverse engineering on the malware and then find the algorithm to figure out what other domain names that it is typically connecting to, right? Fast flux. So a single domain name will point to multiple IP addresses in quick succession, right? So the domain would point to IP address A for maybe a minute, and in the next minute it will be pointing to a different IP address, right? And all those IP addresses are typically controlled by the threat actor, which is part of a bot or a botnet. And the logic behind using fastflex method is primarily so that defenders cannot identify, or you cannot go after one particular autonomous system. The autonomous system, or the IP address is always changing, right? That makes it much more difficult to go after the autonomous system per se. But you can still block the domain, right? That will stop all activity. Then you have, as I said, newly registered domain names, wherein, in my opinion, there are multiple variants to this. There are newly observed domain names, and there are newly registered domain names. So difference is, registered simply means when it was registered, or the registration date, or the creation date. In the context of observed, it might have been registered a year ago, but activity to it, or access to it started recently, right? So when it was observed, especially in something called as passive DNS, right? Then lookalike domain names. Yes.
Hello.
Yeah.
So yeah, generally, when we talk about newly registered domains, it's talked about in global context. Like this is newly registered domain globally, and how does the newly observed domain work? Is it observed in local context or in global context?
That's an interesting question. So it could be, so generic answer to that is, it's in the context of globally. Like, let's say, for example, so one phenomena that is very common is, you will find, so I'll give you a very specific use case. You'll find a lot of domain names, especially malicious ones, pointing at 8.8.8.8, which is Google's open DNS resolver, right? Or 1.1.1.1, or 9.9.9.9, right? So the typical uh, modus operandi here is, the threat actor is registering a domain name, pointing it at these good IP addresses, good autonomous systems, aging it for a while, not doing any activity for 6 months, and then after 6 months launching a phishing campaign, or a malware or a C2 campaign using those domain names. So generically speaking, the NOD, or newly observed domain names, is typically domain names that were registered some time back, but there was no activity when it was registered. And then after a certain period of time, we are now seeing activity pertaining to that domain name, right? I hope that answers your question. Yes. So then you have Punicode domain names, which I'll get to as well, but lot of anomalies, right? In the context of DNS, lot of anomalies, which at the surface I've talked about. So I'm going to slightly pivot and also talk about Opsec here as well, right? Generically speaking, this is something that is part of the adversary infrastructure tracking workshops that I do. But here in this context, it is important because I'll make the point that stop outsourcing your DNS, right? So the takeaway in the next two slides for you is, stop outsourcing your DNS to somebody else, right? Run your own recursive resolver. Don't outsource your DNS to anyone for that matter, right? And it's simple to run your recursive resolver in your network, on your laptop. Like, I run a recursive resolver on my laptop, right? Now, whether you use response policy zones or not, that's secondary. But the next two slides will talk about why you should not be, sort of outsourcing your DNS, right? So question is, when you query for a domain name, or when you try to resolve a domain name, who is going to see what? That's my question. Expecting answers here. Okay.
ultimate destination would be able to identify the source.
So this is a favorite command of mine because this one single command teaches how DNS works behind the scenes, right? The command is drill space hyphen capital T google.com or whatever domain name that you want to give. And hopefully internet works for me. Demo gods are still with me today. So thankfully, the answer is here, but not in the format that I was expecting, because I see there is a lot of content missing, which is interesting. Because ideally, I have to see the entire delegation chain right from the root servers to the authoritative to the GTLD server of .com, then the authoritative servers of google.com, and finally the answer. So I'm only seeing the answer. I'm not sure why. Maybe something funny happening in the network. Sorry? Yeah, but I have my dig is broken. Because both these do the same thing. The drill hyphen T and dig plus trace actually does the same. I like the drill minus T more better because there is a difference in the version of dig on Unix and Mac OS operating systems and the one on Linux operating systems per se. So definitely something funny happening. Okay, let me do it differently. All right. So what I've done is I've logged in into one of my servers on the cloud and I've executed this command. So you see, so what this command is doing is this command is telling you the DNS query right from the delegation, right from the root of the root servers till the final answer, right? So you see at the left hand side of the screen, uh, the dot signifies the root servers, A to M, right? Not in any particular order because there is randomization at play. So the query first went to the root servers, one of the root server asking the question, what is the IP address of google.com, right? That root server responded saying, I am not authoritative for google.com, but I know the authoritative name servers of .com, right? So it gave a referral. I don't know the answer, but the referral is here are the servers authoritative for .com, right? So you see these are the GTLD or generic TLD top level domain name servers for .com. Then then my system sent the query to one of the authoritative name servers of .com. It responded back with a referral again to the authoritative name servers of google.com. Then the query was finally sent to one of the authoritative name servers of google.com and it responded with the answer, right? That the A record or the IPv4 address of google.com is 142, 250, 182, 238 and the TTL or the time to live is 300, right? So this is in a nutshell what is happening behind the scenes when you are making a DNS query, right? And coming back to any questions here? Yes. Because there are 13 root servers, right? In fact, there are 13 root servers, but so it's not 13 servers actually. There are many instances of the root servers, right? So I will not go into more detail about it because that's like going down the rabbit hole. But if you want to learn more about it, you can go on this website, root-servers.org, and that will give you a full picture about each of the root server. So in total, if you see, there are 13 root servers operated by 12 independent organizations, or root server operators as we call them. And in total, there are 1,903 instances at this point of time, period, right? And they keep on adding more instances, right? Like as an example, if I look at the K root server, which is run by RIPE NCC, I think India has many instances like Bangalore, Mumbai, Delhi, and so on, right? So these instances are in anycast mode, wherein the same IP address is being announced at multiple locations, right? So don't get confused by why there are only 13. It's not 13, it is 1903 instances. IPv4, IPv6 again. But I hope that answers your question, right? All right. Any other questions pertaining to this? Okay, so coming back to my question, which was, who will see the DNS query? And there are going to be many players in the ecosystem who are going to see your DNS query, right? First and foremost, somebody in the network is going to see that query, right? Then the recursive resolver that you're using, if the recursive resolver is local, that is going to see your DNS query. If let's say, for example, you're using 8.8.8.8, that is you're outsourcing your DNS, then your ISP is going to see your DNS query if you're using DO53, which is DNS over 53, which is unencrypted because it uses plain UDP. So there is no encryption in place. So when the packet is traversing your network and going through your ISP, the ISP will also be able to see your DNS query, right? So somebody can do a man-in-the-middle attack there as well, right? Then as I also pointed out, when I made that query on my system to google.com with the drill command, the root servers are also seeing the query, right? It's a very important thing to remember because there's a very interesting project called as Day in the Life of a Root Server, right? DITL. It's called as DITL. It's actually run by an organization called as DNS OARC. Interestingly, there was a DNS Community Day that they had organized last year in Apricot, during this time. And they run this day in the life of a root server where they collect packet captures, right, for one full day, like 24 hours. So they are going to see, so if you make any query on that particular day, any packet capture is going to contain your query as well, right? So let's take into assumption that the root server is definitely going to see it, right? Unless the recursive resolver that you're using is configured with something called as QName minimization, right? If you're using QName minimization, then they are not going to see that query. They're only going to see what is the GTLD or the CCTLD that the question that you're asking for, right? And the authoritative name server of, in this case, I've mentioned as a threat actor, but you can search and replace that with any authoritative name server, right? So many people in the ecosystem are going to be able to see what DNS query that you are making. Of course, I'm making the assumption that you're using DNS over 53, right? Then there is something called as edns client subnet as well, right? If you're using a recursive resolver, which is configured with edns client subnet, then it also forwards your IP address to the authoritative name server as well. The reason why it does that because the answer can be closest to your geographical location, right? So there is the answer, there is the recursive resolver 8.8.8.8, which is Google DNS with edns enabled. And you see it is, I gave it the IP address and it contains that response, right? Having said that, here is a recursive resolver which I am running locally, which doesn't have EDNS enabled. So even if I try to send my IP address to the authoritative name servers, it does not send it, right? So this is in terms of also IP address being your IP address of your network, the WAN IP address being sent to the authoritative name server, right? So coming back to newly registered domain names, and I'll also point to why this is something which is to be looked at, is the fact that when we looked at newly registered domain names data on a recursive resolver, right, in multiple networks, one of the things that was very alarming to see was queries going to newly registered domain names where the domain was registered a week ago, right? Or a month ago. And why this is an interesting thing to investigate, why this is an interesting element to look at, is primarily because none of the threat intelligence sources will contain newly registered domain name data, right? So any newly registered domain name will not exist in threat intelligence that you're using in the network, right? So this becomes a blind spot. And threat actors primarily leverage that, wherein they'll register a domain name, then quickly launch using that NRD or newly registered domain name for a particular campaign, right? And one of the point that I always make by saying this is, why would an enterprise, why would a business, an endpoint in a network, communicate with a domain name that was just registered, right? Just doesn't make any logical sense. So it always is you'll always do business with somebody who has built a reputation, who is there in business for a very long amount of time, has built credibility, right? You'll not build, or you'll not interact with somebody who has just started one day ago, right? That's a very edge case. Another source of threat hunting, or from a defense perspective, which largely gets unnoticed, is these services which I classify as what is my IP services, right? So there are many such websites which exist on the internet, like whatismyip.com. And you go on that particular website and it'll show you your IP address, your ISP name, and a lot of other details, right? And one of the interesting things which we see again and again and again is malware actually using these services to identify where the malware has been installed, right? So the threat actor is also very interested to know. It's like analytics. The threat actor is interested to understand, where did the malware that I built or I created, where has it been installed, right? So that they can understand the victim or that network in a much more better way. So a lot of times, and in fact, the MITRE ATT&CK framework, right? So the MITRE ATT&CK framework is basically a framework which talks about the TTPs, the tactics, techniques, and procedures of threat actors. And there is a particular technique which it talks about, that is T1016.001, where this has been explicitly talked about. But a lot of times when I talk to enterprises and I ask them, like, how do you look into these sort of services making a DNS query in the network? And the answer is, we are not looking at it, right? So it makes more sense to look into such services. And there are a lot of open source or OSINT sources on the internet which you can use, which list out all the domain names which are similar to ICANN has IP or whatismyip.com and so on and so on. So you populate that list, you give it to your recursive resolver, and you tell it either block it, right, or log anytime a query to one of these domain names has been made, right? So you are basically getting the visibility as well, like understanding what is happening in the network when somebody does that. So this is the list. No, this is actually not the list. This is probably only for dynamic DNS. So dynamic DNS is again a very interesting use case, because very short-lived. A lot of times threat actors just use it and then get done with it. So there is a list on GitHub. Just a heads up, no affiliation to that particular list. Use it, with your own, precautions pertaining to what exists. Tomorrow, if there is somebody puts a google.com on that list and you are blocking it, users in your network are going to complain because Google is going to stop working, right? So be very careful in terms of open source intelligence that you use. Vet it in terms of what it is actually doing and how that list has actually been populated, right? A lot of open source intelligence is available for free, but it's important to understand how it has been created. Another slight pivot that I'll go into before we get deep into DNS response policy zones is domain shadowing attacks, right? Which I talked about a little earlier, wherein the main domain is untouched and subdomain is basically created under the main domain to launch any sort of threat activity, right? So this is something that we started targeting or rather looking at this particular specific targeted attack in terms of very specific CCTLDs, right? Like .lk, .np, .in as well. Wherein when we started, it was primarily just .lk that we were looking at, that we were seeing in a very large way. Then .np as well. And now recently in the last 6 to 7 months, we have been seeing .in as well, right? And there are probably others. And the idea is very simple, right? To compromise a legitimate domain name, because the legitimate domain name has a reputation, right? That one word is extremely important, reputation, because that gives the threat actor the ability to use the reputation of that particular domain to launch an attack. Two, a lot of times, as I said, the main domain is going to be untouched. So the threat actor is not going to do any changes to the main domain, right? This is how it works. So I'm complying with all RFC requirements. Example.com pointing to 192.0.2.1. Login.example cpanel pointing to a particular IP and an autonomous system. Fish.example.com pointing to the threat actor's infrastructure, right? Or bank.example or c2.example pointing to the threat actor's autonomous system or IP address or a specific IP address in that autonomous system. And how is this particularly happening? It's happening because which I'll come to. But why? As I said, the reputation of the domain, right? Because my domain, my personal domain name, brainattic.in, it's probably been live for maybe 14 plus years, and hopefully I have not had anything bad going on that domain or that on that server, and I don't send spam, right? So the reputation of the domain is very clean. And the threat actors would love it because threat intelligence vendors will flag it as clean, right? But if there is a subdomain under that main domain, then that makes it much more useful for the threat actor. And it eliminates, most importantly, as I said, the point, threat actors are lazy, right? So it eliminates threat actors from buying domain names, because even though they are doing it with stolen funds, of course, they don't need to take that steps in order to get access to domain names. The other one, which is something that I'll get to in more detail, is blocking ads. And this is going to be a little controversial because a lot of times lot of people point out saying that ads are good, right? And sometimes I get good offers when I look at those ads. But there is also something which is very, very in a very small way. It's very niche at this point of time when I talk about threats, but it is growing in large numbers, is called as malvertising, right? Malvertising is basically malware advertising. So when you actually search for something on Google or any search engine, the ad that you see at the very top is actually not a legitimate one. It is a fake one, wherein it appears exactly like a legitimate one. But when you click on it, what it will do is it'll prompt you to download, like as an example, if I'm searching for, if I want to download and install the latest version of Zoom, what I would typically do is I'll go on Google and I'll search for Zoom, right? Now, the first thing that will show up there, which is an ad on Google, which somebody has paid for. And if it is a threat actor, he is not paying by using his own money. It's using stolen funds. It's an ad using stolen funds for Zoom download. And when I click on it, what will happen is it will take me to a fake page, which appears like zoom.us, but it will be something like zoom-us.us, right? And I say download, and it will download a malware, right? So that's why I have listed this here, even though despite the fact that all ads are not bad, right? But malvertising is something that is increasing in a very large way. And users, or even consumers for that matter, how would they differentiate between what is a good ad and what is a bad ad, right? It is, in my opinion, extremely difficult to do that, right? If not impossible. So I would say block ads, right? Using response policy zones, and you will not believe the clean internet experience you will also have. So it's also not about from a security perspective, all the things going away, all the ads going away from a page, right? Saves bandwidth, right? Gives you a very clean experience for you, for the users in your network as well. In fact, I do that on my laptop, wherein I use a piece of software called as WireGuard, right, which is an open source VPN, right? And the WireGuard on my MacBook connects to a cloud instance where I have response policy zones running, which is configured to block ads, right? And some time back, so there is a very popular list called as Stephen Black, right? That's the name of the guy. So this is a very popular list which exists on GitHub. Earlier, it used to be the host file on Windows systems to block all this. The same list also exists. And sometime back, Dr. Paul Vixie and me got behind this. The people who run the repository to basically port the data from the Stephen Black host file to a response policy zones format, right? And thankfully there were good people supporting this idea. So there is a response policy zone available for this. I don't think it's there on the or mentioned on that link. Yeah. Yeah. Please.
So actually, can you go back to your presentation?
Sure.
Yeah, just a slide backwards. Yeah, this one, right? So the example.com one.
Okay, sorry. Yeah.
Yeah, so I run example.com, right? That's my domain. And I mean, like, if someone is a threat actor and he wants to register bank.example.com, means I need to have that delegation, right? I need to do that delegation. He cannot just simply go and register bank.example.com.
Absolutely right.
So basically, example.com would be like some changes in A, maybe, or P.
So if I have to understand your line of thinking and the question, how is this attack happening?
Yeah.
Right. So the attack is happening wherein the DNS control panel of the registrant is compromised.
I see, okay.
Right. So, and in most cases, what we have seen is threat actors doing a brute force on the DNS control panel to gain access, number one. Two, there have been instances where users' login details have been available on the dark web, right? So those details, in certain cases where users are using the same details, login credentials, like the same password for XYZ service and also the same password for their DNS control panel as well. That's the overlap. But in most cases, it's a brute force attack on the DNS control panel. That's how the threat actor is getting access to the domain. and then not making any changes to the main domain because they want to hide the trail, and then add the subdomain record so that it points to the threat actor's infrastructure. So that's pretty much how it is happening. So the feedback to registrars and registries is to have two-factor authentication enabled, not have the same password for all your users, right? So whatever domains are being created, not having the same password for everyone, right? Having a unique password that is being system generated and forcing the user to probably change the password, right? The other thing which, in my opinion, which is also going to be useful, but it is not being done, like in our email accounts, right? So whenever you log in into an email account, let's say I log in into my Gmail, I'll get an email or a message saying that somebody logged in into your account from this geolocation and so, right? I would say if registrars and registries could build that system, right, wherein anytime a change is done to the zone, a record is added, record is modified, record is deleted, a notification goes to the registrant email address saying, notifying that there is some change that has been done to your DNS, right? So now that's a little difficult thing to also comprehend because a lot of times in general cases, not everyone is technical, right? In most cases, they are not technical, right? But at least notifying that this has changed. Like if you have not done this change, then probably reach out to somebody to get understanding that this change has happened, right? Question? Yeah.
Sorry. So no, it was just a comment that a lot of this DNS for subdomains are being managed by the domain owner, and a lot of times the RIRs or the main registrar doesn't have the enough visibility around what I am making changes to my domain due to my own NS server with all the Route 53 and Azure DNS and a lot my own local DNS servers. Uh, I believe that it would be my responsibility to monitor that. Somebody else would not be monitoring that. Let's say if I add a new subdomain, probably Google would not know until Google is queried for that specific subdomain because I'm the authoritative domain name server. And the other angle to that is to your point that attackers are brute forcing, and I've seen very few cPanels which would support logging of those authentications on the cPanels. Uh, if that's being compromised, most probably nobody would know.
Right. So agree on the point that, since you're controlling your authoritative name servers, then you would have. I was sort of making the perspective for the non-tech people. Everyone is tech here, but generic case non-tech people, which is the majority on the internet, there it's if a change is happening to a domain name, then they're not knowing about it. They are completely in the blind, right? But yeah, absolutely agree that it's for us. So one of the things which is useful to do in that case is to monitor the zone file, right? And have sort of automation in place which will trigger an alert anytime a change is happening, right? The second way to also do that is use passive DNS, right? So passive DNS will also tell you when there are subdomains being created. Not This is not a 100% solution because many a times passive DNS can also have blind spots. But most cases, depending on the passive DNS provider that you're using, it will be able to tell you that a subdomain was, historically pointing from this to this IP address from this period to this period, right? So it'll be also useful to do that. One second, does that answer your question? The earlier part, yes.
So as you mentioned, there have been domain shadowing attacks. So is it possible to have the reputation of domain being highly reduced because of some malicious subdomain level addresses? So how is the reputation of domain calculated, and does it hampers if I do something bad in the subdomain level?
It's a very loaded question. because I think there is no, so I'm going to answer this from a threat intelligence perspective. So there is no standardization pertaining to this. So every vendor would treat it differently. Some threat intelligence vendors would say, because the subdomain is bad, everything under that domain is purely bad. Some would be very specific, subjective, saying that only that subdomain is bad, but the main domain and other subdomains are not bad, right? So that's a very subjective thing, and there is no industry standard to it which says that okay, this is how it has to be done, right? So every threat intelligence vendor is going to treat that case very differently, right? Unfortunately, that's the case. Yeah, so I was talking about Stephen Black, and so the website is scripttiger.github.io, and additional blacklist support. If you go on that page, you will see the various lists of that particular Stephen Black host file, and here you see RPZ, right? The response policy zone format, which I'll come to later, but it's also been ported to that. So you can use this in your recursive resolver and block all ads, or not block, only log, right? So there are many possibilities to it, right? So let's say, for example, you don't want to block anything, that's also possible. You can only log it, but that will also tell you how many ads in your network are getting accessed on a per day basis, right? And the amount of queries that it is generating. So on an average, I've done some sort of experiments. This is very subjective. On my MacBook alone, I think the average number is around 20,000 DNS queries get blocked per day, right? But that's a subjective, analysis, because what you access, what domains or what websites you access, what services, it'll all be dependent on that, right? And also be careful about false positives, right? So don't take it as a source of truth. The open source intelligence, also verify and have a system in place to make sure it doesn't block legitimate stuff, right? Okay, how much time do we have? 8 minutes. So I'll quickly go through the basic idea behind a response policy zone, right? So I think I've pretty much talked about the basics of DNS 101. I've talked about threats using DNS, talked about anomalies in DNS. And now we talk about how to use DNS response policy zone to mitigate identify or detect threats as well, right? So this is not a RFC yet, but as I said, it has been supported by pretty much every open source recursive resolver software there is, right? And there are a few. So Bind is the most famous or the most common one. Then you also have Unbound by the kind folks at NLNet Labs. Then you have Power DNS, which is Power DNS recursor to be specific. And then you have Knot DNS as well. Knot DNS, yes. I hope I got that right. So this was purely called as DNS Response Policy Zone, right? Like a DNS firewall. That was primarily the idea. And it's basically a vendor neutral format. So there is nothing proprietary about it. It's similar to the zone file format you have in an authoritative name server, right? So if you have ever configured a zone file in an authoritative name server, the format is very similar. It's a flat text file, right? Or multiple text files. And you can do a lot of things in those text files. Like, say for example, you don't want to block, you want to find out every query that is going to a particular CCTLD, right? With geopolitics at play in a very large way, this has become a sort of a norm, unfortunately. I want to find out a query that is being made to a particular CCTLD or a GTLD, right? I can create a zone file in response policy zone format. I can put in the logic, right, which is very simple. save the file and reload the recursive resolver software, and boom, it will start logging any query made to any domain under a particular CCTLD. It will log it in that log file, right? I can even block it. I can even do the blocking as well, which I'll come to later. So there is IETF internet draft by Dr. Paul Vixie and V. Shriver. I hope I did not butcher his name. It's not a standardized protocol, as I said, but it's pretty much there in any open source software, recursive resolver software. So the basic idea is very simple. Idea is to, in one word, lie, right? So even if a domain name is existing on the internet, in my network, it will not exist, right? So my recursive resolver software is going to lie to the endpoint saying this domain doesn't exist, right? And very importantly, I forgot to mention, it's also called as protective DNS, thanks to CISA, which is the cybersecurity agency in United States. It decided to change the simple naming from DNS Response Policy Zones or DNS RPZ or DNS Firewall to protective DNS, right? I don't know where it came from, but if you hear or if you see the word protective DNS or DNS Firewall, DNS Response Policy Zone, all of them mean the same, right? And what you can plug into the recursive resolver is now threat intelligence, right? And the threat intelligence could be proprietary, it could be open source or OSINT, and it could be something that you are seeing in your network, which is localized, right? And you would like to block it or log or do anything with it. All that is possible, right? So the recursive resolver sort of becomes a very powerful tool to get control of all the access pertaining to DNS, right? This is your authoritative name server with a zone file, right? And you can see the domain name is instaping.in. It was one of my domains earlier. And it's a very simple zone file containing DNS records, right? Where, sorry, instaping.in is pointing to a particular IP, webmail is pointing to IPv4 address is given, then there is www and so on, right? This is a very simple DNS zone file. And then what you have is the response policy zone file, right? This appears too much text, but it is actually, don't get intimidated by it. It's very simple. So on the left-hand side, you see the domain names. Then you see CNAME dot. So what it implies is the logic here in the zone file is any query for any of these domain names, give a response NX domain, right? So in DNS, you have something called as responses. So NX domain stands for non-existent domain name. So even though the domain name might actually exist on the internet, the recursive resolver will lie to your endpoint saying that this domain doesn't exist. And then it will also log it in a log file, right? So this is only one of the ways in which this works. Now there are many ways in which this can be tuned, many ways in which you can configure it, but this is the simplest, right? And what it does is it gives you the ability to take a bunch of domain names and block it, in a very straightforward, very simple way, without any complicated process, without any proprietary element to it, right? So if you're not running your recursive resolver, first thing is to run your recursive resolver and then integrate intelligence into the recursive resolver to basically to log or block, right? I think I'm going to stop here for the coffee break. And hopefully once you come back, and I'm hoping that you have not had enough of DNS, I will also talk about many more things that you can do with response policy zones, right? So see you at 11:30. Thank you.